So in this video, we're going to discuss how to build a guitar pedal. We're going to go from start to finish, starting with reading the build doc and getting the bill of materials, or BOM, and then finish with an actual functioning pedal in our hands. If this sounds interesting to you, keep watching this video and make sure that if you haven't subscribed, please subscribe. You'll also note in the description below that we'll have this broken up into sections, so if you need to continue on where you were last off at, just click down there to get to that section. And with that out of the way, let's get to building. So first we're going to head over to our site, which is www.diyguitarpedals.com.au, and under the category section on the left here, we're going to click on the DBE PCBs link. And then once we're here, we're going to go over to the center here, grab the top one, the Super Siberian. That's going to be the pedal we're going to try and build. And then we're going to scroll down towards the bottom here where we have a link called Build Doc and Schematic, and click on that. Now, once this loads up, scroll down a little bit, and you'll see several options for the BOM. This might look a little intimidating at first, but as you get used to looking at these, they'll become more and more familiar, so just hold tight and we'll guide you through this. With this build, you can kind of see that there's several different ways and combinations you can build this guy, so we're going to set this up in a easy to read way. After reading what options I can have on this one, I'll be building the Green Russian version with a modification though. I'm going to use the Super Siberian modified here. I'm going to make sure that I get the clean and mids mod, but I'm not going to do the gate mod on this pedal. And I bring this up to say that this is what I find kind of fun about building guitar pedals, is the fact that you can customize these things. So you can kind of make it your own as you add and subtract things or change values. And to me, that's important. Because I'm doing these modifications, I will primarily be looking at the BOM here, or the Green Russian, or the Green Super Siberian. But when it comes to the sections here where it says do not populate, I'm going to look up here for the Super Siberian modified ram's head, because that has those values populated out. When it comes to Big Muff Pi mods and variants, there's usually 4 stages, and they're all kind of in that same topology, meaning the circuit more or less looks the same, but just has values altered a bit to alter the sound slightly. I say that to say this: if the parts are not exactly identical to what is on the BOM in this particular pedal, this pedal is actually pretty forgiving in regards to tolerances and whatnot. So that means you basically have a lot of wiggle room, which is why I think this is a good beginner circuit. Anyways, let's look at the BOM for the Green Super Siberian, or the Green Russian mod. The BOM is broken down into sections. First, we have the capacitor section, and in most cases we use 3 different kinds of capacitors. If the capacitance is under 1 nanofarad, we typically use ceramic capacitors, or if they're in basically the picofarad range, so to speak. Typically we use the ones that are known as C0G or NP0 formulation. At these small capacitances and formulations, ceramics usually do the best job and are the least noisy. If capacitance is between 1 nanofarad and 1 microfarad, we typically use film capacitors, sometimes called box or polyester film capacitors. These have very little noise and are probably one of the most common things you'll find in a guitar pedal, aside from resistors most likely. If the capacitance is equal to or greater than 1 microfarad, then we typically use electrolytic capacitors. These are polar devices, which means you will need to install them correctly. They can go in one of 2 ways, the right way and the wrong way. And the correct way is usually labeled on the PCB with a marking indicating which side is positive and which is negative. And on the capacitor itself, it'll have a stripe of negative signs indicating the side is negative, and making sure that obviously when you install it on the board, negative goes to negative, positive goes to positive. Another thing to note too is if you get a brand new electrolytic capacitor, it usually has 2 different lengths on their legs. The long leg is typically positive. As a physical size, we typically use 5mm diameter for 1 to 9 microfarads, 6mm diameter for 10 to 47 microfarads, and 8mm diameter for anything above that. And because we're doing the clean mod, we're going to be populating C15 and C16 with 100 nanofarad film capacitors, as indicated right here. The next section that we got are the diodes. We typically use several kinds. In this build we have two kinds, fast switching diodes, which are these 1N4148s, which can also be substituted with 1N914s, and then rectifier diodes, such as this 1N4001. The next section are the transistors. Because we're going to be doing the clean mod, we will be populating all 5. In this case, we typically use what are known as TO92 footprint transistors, which is a small 3-pin package, but there are other similar forms that they can also come in, but in this pedal it'll just be TO92 footprints. The next section are the resistors. Most of the time, guitar pedals are using quarter-watt resistors with either 1 or 5% tolerances, depending if they are metal film or carbon film respectively. Nowadays, the majority use metal film, as the cost is about the same, the tolerances are better, and they seem to be less noisy than the carbon film alternatives. As this is a fuzz pedal, either is going to really be fine, and because we are doing the clean mod, we'll be populating R24 through R28, and instead of shunting R29, we'll be using a 10K resistor that is based off of this Super Siberian modified section right here. Just a note too, if you're using 8th watt resistors, you can use those in this build because 8th watt will be good enough. Anyways, for potentiometers, we're going to use the Super Siberian Ram's Head as our guide for that, so we have our clean and mids mod. Note that when we look at potentiometers, there's a bit of information here. Firstly, we have the size of the potentiometer, 16mm, and sometimes you'll see 9mm. 9 are the small ones with usually like the little green plastic on them. They're usually used for smaller size pedals that are more densely packed. And then we have the larger 16mm ones, which are the ones that a lot of people are used to seeing. In this case, the next thing you want to note is the size. So this volume potentiometer is 100K. The tone is also 100K. The cleans is 100K. The sustains 100K. And the mids is 25K. That is a matter of how much resistance that potentiometer has. So you want to make sure you got that part right. And then that last letter, that indicates the taper of the potentiometer. So how you twist it, depending on that taper, will depend how the resistance change as you twist that potentiometer. So the A is the audio taper or logarithmic. B is a linear taper, so it's more of a flat line. And then C, which we don't have on here, is a reverse logarithmic type of a taper. I also want to note too, once in a while you'll see the W taper. You don't really see that too often, but if you're making a Tube Screamer variant, you'll probably see that. Another thing to note here too is substitutions, because as of the time of making this video, we are out of the 100K audio taper potentiometers, but because of this circuit, we're going to substitute all the audio taper ones with linear ones, and it will be fine. This pretty much gets our PCB parts all situated, but now we have to have something to put it in. So let's talk about enclosures for a moment. So if we go onto our site here to enclosures, you'll see that we typically have 4 kinds of pedals, or pedal enclosures, I should say. We have the 1590A, which a lot of people call the micro pedal enclosure. They're really small. They kind of limit you in your PCB size and your component choices, as well as your hardware choices, just because of its tiny size. But there are some simple 1-knob pedals that can be done with these, and if you're really good at cramming them in there, 2-knob pedals. The next size up would be the 1590B. Some people call these the nano pedal enclosures. You'll see like Electro-Harmonix usually uses the term nano when they're using this style of an enclosure. This one's rather popular with DIYers because even though it's small, it's not so cramped that you're limited with a lot of the hardware. I mean, it's actually pretty easy to stuff a 3-knob type pedal in one of these enclosures. It is a little bit difficult to get a battery in there as well, but you can. And it's pretty difficult, next to impossible, I would even say, to try to make it a top-mounted pedal. But for a small side jack-mounted pedal, it's pretty easy to work with. Next size up from that is the 125B. A lot of people kind of call these the boss pedal style enclosures. Obviously, it's not a boss enclosure without the whole switch thing that it has going on there, but the general idea of the shape and amount of stuff you can cram into it is pretty similar to that of a boss pedal. These ones are pretty popular because these ones are small enough that you can still put a lot of stuff in a small space, but you have the room for top-mounted jacks. So that's kind of a desirable thing, especially nowadays. Another thing that these ones are good for is obviously now you have the room for the battery that you're looking for if you want to make a battery-style effect pedal. I'm not really a big fan of using batteries because everyone has power supplies nowadays, but it's there for those instances. And then lastly, the next size up from that is the 1590 BB, which is what this pedal that we're building is going to be using. These ones are rather large, but not supremely large. They're used when you typically have a lot of knobs and switches on a pedal. So once you're in that realm of like 6 switches or 6 knobs or whatever, that's where you want to start getting into 1590 BB. You'll see a lot of Strymon pedals, for example, use that size because of all the options they put with switches and knobs and whatnot. And they need to have the physical room to mount them. So that's where a 1590 BB comes off. So, and then as of like finishings, I prefer usually getting my pedal finished with a white powder coat or a cream powder coat because I can just print my own labels or get someone to paint for me. But if you want to get into like doing your own finishes and whatnot, you can either get them pre-powder coated or with a bare finish, and then you powder coat them yourself. We've gone over some videos on finishings for enclosures, so I'll put some links in the description below going over that if that interests you. Alright, we have our PCB, our components for our PCB, and an enclosure. So what's next? Well, we need a means to tell our effect to turn on and off, and a way to see how it's doing that. So for that, we're going to need a stomp switch. So if we go over here to switches, we're going to be looking for the typical way of doing it, which is the triple pole, double throw, latched foot switch, which at the moment we appear to be sold out, but I think we're restocking that here at the time of this video. But with this kind of a switch, this will give us the ability to turn our effect on and off, and to power certain things on and off, and to turn on an indicator light on and off with the effect. So coming up to that whole indicator effect, let's take a look at another thing here, which is a PCB to mount that switch on. So if we scroll down here under the DIY GP PCBs and kits, we get down towards the bottom, you'll see this one here called Compact 3P DT Wiring PCB. This is something I would highly recommend getting just because it makes placing the switch and getting it wired up a lot easier. It also gives you a spot for your current limiting resistor for your indicator LED, which is kind of helpful. And so yeah, that's something you definitely want to take a look at. If you get one of those from some other location, sometimes they're nice enough to give you a spot to mount the LED on top of it with standoffs. That's something to also look at as an option. But having kind of a PCB for your switch is kind of a good means of getting it wired up and wired up correctly. You don't have to use a PCB like that. You can just bare wire the switch up to the PCB into the jacks, and that would work. But like I said, that kind of helps having that PCB there. And then as of LEDs, we'll need to be looking at that. So anything that's kind of a 5mm LED is a good option. 3mm LEDs work too, but I tend to go with the larger ones just because they're easier to handle. And then another thing you can look at too is a means of getting it mounted onto the actual enclosure. What a lot of people do is they typically drill out a hole and then place a 5mm LED holder in its place. Or if it doesn't have standoffs and it's just kind of free wire floating, they'll get one of these kind of metal bezel holders for a 5mm LED. So that's some options that you can do right there. All right, anything else? Well, we need jacks to plug power into and something to plug our guitar cables into. So let's go over to hardware. And where is hardware? Down here. So what we're going to do is we're going to look for 2.1mm DC jack switched. We'll use one of these for power. 2.1mm is what you typically see with most guitar pedal power supplies, so that's what we're going to stick with. And then as of audio jacks, we typically use 6.35mm jacks or 1/4 inch for us folks in the United States. And these mini mono ones are kind of nice just because they're rugged and pretty compact. So we'll get 2 of these guys, one for the input and one for the output. And lastly, we need wire to hook up the audio and power jacks, as well as to hook up the Stomp switch to the main PCB. Typically, we use 24 gauge stranded wire. So let's go over here to the wire section. And yep, that's what we got right here. 24 gauge stranded wire, although solid core wire also works well, especially with smaller gauges like 28 and 26 gauge solid core. As a matter of fact, a cheap way to get some wire when building a guitar pedal is to pull out the twisted pairs from a dead Ethernet or phone cable. Just make sure, obviously, that the wire itself isn't dead. Another option, too, is if you're looking for stranded wire that's kind of stiff, you can get what's called top-coated wire, which is actually already pre-tinned, quote-unquote, if you will, inside the wire. So you just have to strip it, and the tinning's more or less done for you. That's what top-coated is. So, all right, we went over all the things that we need to purchase. So if we were to go and buy this, we just add to cart, and then obviously we're going to have to add all those parts that we mentioned before. So once we just order all those parts, we just got to wait for them to arrive. But one thing to note is our store is located in Australia, as Paul resides here, Paul being the owner. The prices here are listed in AUD, Australian dollars. So you want to note that when you're converting your currency when purchasing if you're not inside Australia. As myself, I'm over here in the United States. So at the time of this video, the exchange rate for Australian dollars is 71 cents United States currency, £0.5 sterling for those folks in Great Britain, and 0.63 euros for those who use euros as their currency. But anyways, just remember to convert your currency when you're buying this, because I know a lot of people here in the United States get a little sticker shock when they see the $14 and go, wow, that's kind of expensive. And it's just like, yeah, that's in Australian dollars. Make sure to remember that. Anyways, let's order this stuff, and we'll wait for our parts to arrive. All right, so here we have our PCB. With the Super Siberian here, you can see that this is kind of a little bit of a unique layout. We have sections actually broken off. So if you look at the schematic on the build doc, you can actually see not just the schematic from a drawing standpoint, but from even a layout standpoint. So first thing we're going to do is we're going to start putting on our resistors. So you just go through the BOM and start working your way down. So the typical way to put in resistors, you just take your resistor and you bend it at a 90-degree angle. And then you look for the mark on the board. So in this case, I'm looking for R1. And we're just going to put R1 onto the PCB like so. And then we'll flip the backside and bend the legs. And then we can solder it in. Now, mind you, this is a little bit tricky to do from a camera angle here. But you just heat up the pad for a second. And then wait for it to glob on. Now some of these are going to be a little bit tricky because they're ground planed solder joints. So they take a few seconds to heat up. Then we just bend them back. And then we just snip them off. Oops, there we go. And so there we go. We have a perfectly good solder joint on our board. So I'll save you the time of watching me solder, because there's probably much better tutorials out there on how to solder properly. But what we're going to do is I'm going to demonstrate basically layering up the board. So the first thing you want to do is your resistors, and then in a moment here we're going to fast forward and go through the rest. All right. So here we have the resistors all soldered on. So the next step we're going to do is solder on the diodes. We got 4 switching diodes here, and then we got 1 rectifying diode here. One thing to note is when you're placing it on the board, like certain capacitors, like electrolytics, these guys are polarized, so look for that stripe. And here's like the stripe here on the switching ones. You can see how it's got like a little bit of a black stripe on the tip there. And the idea of placing these on the boards is just like the resistors. You bend them at the appropriate right angles, and then you place it on the PCB where it's located. And you can see here on the PCB how it has a stripe indicating where that stripe goes. So make sure you match the stripe with the stripe. All right, so now we have the diodes on the board. Come on, focus, there we go. And the stripes are matching. Now you probably notice that the leg gap between the switching diodes is rather large, larger than the actual diode itself. We did that so that you would have room for putting things on there, such as fatter Schottky diodes or germanium diodes even, which do have a wider footprint. But it doesn't matter, as long as you just get the legs through the holes, solder them, make sure that the stripe is on the stripe side, and you'll be fine. But anyways, now that we have the diodes and the resistors on, as you can see, the board's pretty flat, and there's not a lot of height in material coming off of this. So this is where we start working on the more taller things. So the next things we're going to put on the board are these ceramic capacitors that we have on here. So let me put those on, and then we'll move from there. Okay, so now we have the ceramic capacitors on the board. They're not polarized, so it didn't matter which way we installed those guys. So the next thing we're going to do are the transistors themselves. As mentioned before, this is a TO92 footprint. This is going to focus in that well. I guess not. But anyways, this is just a regular 2N5088, and we're going to install these on the board, and then we'll go from there. All right, so now we have our 5 transistors in place. These are kind of a special thing to note. They're usually shaped with this little like half moon and a flat side kind of a deal on the PCB to indicate the footprint. So as long as you're using the transistors that are called out on the BOM, these should just, fit with the flat kind of deal. However, there are other transistors you can use, and sometimes the pinouts are different. So you do want to know which one is the base, the emitter, and the collector pin on your transistor, and make sure that they actually line up with what's on the PCB. But with that out of the way, let's move on to the next component, height. Now, if we had any ICs, we could probably put those on right now as well. However, this board's pretty much all jelly bean parts, not including ICs. So we're going to be putting on some capacitors right now. So here's our film capacitors or box capacitors. They're not polarized, so we can put them on whichever way we need to. So we're going to populate the board with those next. All right, so now we have all of our film capacitors on there. And the last part we have left is our one electrolytic capacitor, which we use as a bulk capacitor. And here's where I was remember what I mentioned earlier. It's like you got the stripe with the minus signs on it. So there they are. And then I also noted that the longer leg is the positive node on the capacitor, the positive lead. So on the PCB, you'll notice it has a little plus sign right there inside where it says C14. So we want to make sure that that plus side goes in as such. And let's solder that guy in place. All right, so now we have our electrolytic capacitor on there. So the next stage is to get these potentiometers on here. So here we have one of the B100Ks. This has what is called a spline shaft. So you can tell that because it's got these little cutouts in it. And this will be what we'll use for, like I said, for the tone control and such. We have a dust cover on the back. These are nice, not just because of a dust cover perspective, but the way that these mount on the board. This guarantees that the bottom part of the potentiometer doesn't contact any of these metal pieces that are sticking out on the bottom. Another kind of shaft that you'll also see with potentiometers sometimes is this kind right here, which is known as a smooth shaft. And that's, so you can see the difference between the two. And note what kind of shaft you have on the potentiometers, because that's the kind of knob that you're going to be installing based off of that shaft type. So let me solder that on. We'll go from there. Okay, so now we have our PCB complete, minus wiring and whatnot. So what we're going to work on next is, in this case, I did actually get a PCB here to mount our Stomp switch. So let's solder that guy up. So here we have the PCB for the Stomp switch wired up. It has a reverse polarity diode on there. I just populated it because I could, really. I didn't have to because the other board has that, but there you go. We have a current limiting resistor right here. I'm using a 4.7K resistor. The higher the resistance, the dimmer the LED. The lower the resistance, the brighter the LED. And the LED is right here. We're using a 16mm standoff. That usually pairs well with these types of triple pole double throw Stomp switches. So now that we got these guys all in, let's drill out our enclosure. Okay, so now we're gonna have to drill out our enclosure. So to do that, we need to go to the PCB project again and go back to the Super Siberian and scroll down here, and under the build docs and schematic, let's open that guy back up again. And at the very bottom here, underneath the schematic, well, the PCB dimensions here, and then we'll have a layout for the actual drill template. So we're going to print this out. Make sure that when we print this as a 1-to-1, because that's how it was drawn out. So when you get what you get out of the printer, it'll be a 1-to-1 ratio for your enclosure. All right, so here I have my 1590 BB enclosure. I had a buddy here who could hook me up with a silkscreen printer, so this is our little design that we came up with for this guy. And then we have our drill template from the website printed out and cut up. So the idea is we're going to fold this guy on the appropriate lines, of course. And then we're going to cover the outside of the pedal enclosure. And we'll simply just use some tape and get it all closed up before we drill. So once we have this all set up, you just set it up to be drilled. Now, you don't have to have a drill press like I have. You can actually just use a regular cordless drill, but a drill press does give me a little bit more leeway for accuracy. But like I said, even a regular standard wireless drill will do the job. So first we're going to drill the top, and then we're going to, or I should say the sides, how you want to call it, where the power and input and output jack are going to go. And then we're going to do the front-facing portion, which has all your knobs and your Stomp switch and your LED. All right, and then once we got these all drilled out, we just pull the paper off. Make sure you do it over a trash can, because there's probably a lot of the metal filaments floating around in there. But then that's really it for drilling out the enclosure. Okay, so here we have our wires all laid out here. I typically use a little bit of color coding to keep things straight, so I'll always try to keep black wires for my grounds, red wires for the hots, and then I'll use some other color for my ins and outs. So you're going to want to have 6 wires here that are about 5¼ inch or 130 millimeters long for what will ultimately be going from the Stomp switch to the end of the enclosure. And then we're going to have another 4 right here, which just go from this PCB to this PCB, keeping them somewhere around 3 inches or 75 millimeters. So let's wire this up. All right, so now we have everything wired up. One thing to do note is one of the things you don't want to wire up immediately is going to be your power jack, because you're going to be putting that into the actual enclosure. Then the next thing you're going to want to note is when you're doing these audio jacks, make sure that the tip right here is going to the signal. And you can kind of tell that that's got continuity there because the metal's physically showing. So the other one is the sleeve, which goes to ground. And you'll want that on both of the in and out audio jacks. So the rest of it's kind of self-explanatory. So let's put this guy in the enclosure and close it up. All right, so here we have our pedal all wired in and assembled. So if we flip over here, we have our power now set up correctly. So we have the center going to the negative and then the positive going to the outer leg on the power jack there, because most power supplies for guitar pedals are center negative. But there you are. So let's put some knobs on this guy and give it a quick listen. So here we have the pedal all assembled with our knobs on, and we're going to do a real quick sound sample. This is with my baritone guitar, volume knobs on max, tones at noon, sustains at max, mid is about at 11 o'clock, and the clean is barely on. So here's my clean signal. And here's with the fuzz pedal enabled. It also cleans up pretty good if you turn the volume knob down. But not as clean as, say, a fuzz face, but it cleans up pretty good. And let's also take a look at how it sounds with bass. And here's the bass. Because we have the clean knob here to blend in the dry signal, we can actually get our dry bass signal through the fuzz, but still get that distortion. Check it out. So that's the DBE Super Siberian Fuzz pedal. It has a unique layout, making it easier to relate the schematic to the PCB. It has many options to customize, such as a clean blend to make it more bass friendly, a mids control to make it cut in the mix better, and a gating option for that sputtery Velcro fuzz sound if that's your thing. You can pick yours up today at the DIY Guitar Pedals store. I'll leave a link for that in the description below. Anyways, that's it for this video. If you like these kinds of videos, press that like button, and if you haven't subscribed, please subscribe. If you want to help support us, please visit our store at www.diyguitarpedals.com.au and check out our parts, PCBs, and kits, as that'll help us out a lot. So, as always, thanks for watching, and we'll see you in the next video. Cheers.